Hello, thank you all for joining me on this webinar about file transfers in HPC or high performance computing workflows. And this webinar is really as a predecessor to our precursor to our presence at the ISC show in Frankfurt next week. So thank you for attending. For those that came earlier and we couldn't connect, my apologies. We're doing a recorded webinar this week because we had some technical issues starting this webinar. So, hello, my name is John Tkaczewski. I'm the co-founder and president of FileCatalyst. I will be at the ISC show in a week in Frankfurt in a week's time. So if you have any questions, do not hesitate to ask me there. So for those that already know what's HPC or high performance computing, it's a practice of aggregating a lot of computing power in a big cluster to solve very large computing problems. Those problems, take a lot of computers, put them together, and you create a cluster of one big computer, and then you solve a lot of data. So with anything with anything with HPC, files are very large, both the input data as well as the output data, and somehow this data has to be moved. And this is where FileCatalyst comes in. The applications for where HPC is used a lot is used for genomics, for sequencing. It's used in oil and gas exploration, where it costs a lot of money to drill. So before you actually start any exploration or drilling, you want to do some computing research to figure out where to drill. There's of course a lot of more in science, as astrophysics, particle physics. There's a lot of different projects that use supercomputing power, and as well as in weather, climatology, and air science is also very, very big, where you have a lot of applications for that. And all these problems usually deal with very large data sets, and this is where FileCatalyst comes in. We can help moving these data sets. So where can FileCatalyst help? Well, it can help you move your large data sets, your large files to and from a cluster or between clusters. It can help you with migration of data and backups or archiving of data that you have run, simulations you have run. We can accelerate data to object storage as well. We have integrations with some of the leading cloud and object storage providers, including S3, Google, the Oracle open source, so SwiftStack. So all of these are included, so you can very quickly move data to object store. We can automate the distribution of the results. We can also automate the input of the input data, and as well we have web-based file transfer applications. So if you want to create, for example, uploading files via the web, which will then trigger some kind of a job on a cluster, we can provide you with that as well. So how are files sending? Well, of course, everybody knows that there's FTP, SCP, SFTP, and all these other tools that are TCP based. Those are maybe not ideal, but that's probably the biggest portion of the world. Some other shops might be using Globus or Grid FTP. Once again, there's the problem with the TCP constraints to be sending files. You can physically ship the content, shipping hard drives, disks. Some solutions might be using an Aspera solution, where the speed is, you'll be limited to some kind of a speed of maybe a gig or 2 gigs. We can reach 10 gigs and beyond with FileCatalyst, so it's much faster. And there's some open source acceleration tools such as UDT or Tsunami, where there's some reliability issues with that. Doesn't work very well on networks where there's some packet loss and there's no checksums built in. So there's quite a few tools to use today for file transfer. FileCatalyst is another alternative to this. And as you will see in this demo, and under certain workflows, that the FileCatalyst can definitely help you a lot. So what's our goal in our with FileCatalyst? Well, we concentrate on file transfer for the enterprise. So that's our main file. We built all kinds of file transfer tools. We've patented our own UDP algorithm for transferring files. So instead of using TCP-based file transfer, where there's a lot of acknowledgements and a lot of dead air to wait for the acknowledgements to arrive, we send data flow is continuous with FileCatalyst. If you have, where else do we work? We work also with try to simplify these. So our tools are really simple, that simple to transfer files. So for the end users, this is simple. For administrators, there's lots of settings, but that's the flexibility of the software that comes in, where administrators can, make our solution fit into their existing workflow. We provide integration with API and SDK, with our own SDK, with Java and C++. We provide a big management layer, management fabric called with Central, where it allows you to do a full monitoring of all your transfers, raise alarms. I'll be talking about the menu. And as I mentioned, our cloud integration with object storage, OpenStack, Azure, S3, and so on. So this is sort of our goal. So as you can see, we're a company completely based. We're based in Ottawa, Canada, and we're completely concentrating on file transfer problems. So some of the how do we accelerate this transfer? Well, we use the UDP, as I mentioned, to move the files. So we're completely agnostic to latency and packet loss on your network. So if you need to send a big data set between, I don't know, Europe and North America, the latency on the line is not going to affect your speed. You're always going to get full bandwidth. Same thing with the packet loss. The degradation on our speed is as much as the packet loss. So the 2% packet loss means a 2% loss in speed, versus TCP, your loss is going to be probably more like 75%. Once again, I know that a lot of people in HPC work with perfect networks. The problem is this not your network. The problem is as soon as you try to hit the internet and you want to move the files over the public internet, well, now you're going to be facing a packet loss of at least 0.5% on those links. So it doesn't matter unless you have private links where you can guarantee end-to-end. Then you will have to look at the tools that are friendly to packet loss. We provide you with compression, as well as ability to do zip chunking, where you to send thousands of file sets. We can put them in sort of a tarball and send one file instead of sending 1,000, which will take a long time. I'll get to it later. And we can do incremental transfers. So let's say you sent one file set, that file set changed. We will send just the deltas. We will not send the full file. With automation, it just allows you to schedule your transfers, let's say at midnight, check for new files on the cluster, and download the DI results automatically if there's anything new. I'm going to add as well to this the whole management and visibility layer to all your transfers, which also will help you. So some of the unique HPC features that our customers in the HPC world use. So we can easily do 10 gigabits with encryption and with latency and packet loss on the line. Doesn't matter how far the 2 points are. So you need to send data from Frankfurt to Singapore, no problem. You'll get a full 10 gig line over public internet. We mentioned we'll have automation, encryption, reporting, monitoring of all these transfers. We'll give you ability to set your UID and GID permissions on file sets. So when you're moving files from one Linux machine to another, all of this will be maintained. We can transfer 1 million files in a single session. Once again, this is good for archival projects. And we also will provide you with zip chunking and compression. So zip chunking allows you to send thousands of files without opening 1,000 of sockets and ports. We'll send files in a single archive, sort of like a zip archive. It's more like a tar archive that is not compressed, and this allows us to send files very fast, even if they're very small. We provide you with the object storage I already mentioned. We can transfer empty folders, which sounds trivial, but a lot of file transfer solutions don't necessarily do it. And we're definitely faster than any given free tool today, rsync FTP, grid FTP, and so forth. So here's we work with a lot of HPC companies already. Here's some example in energy. We work with GE, for example, on the global research and on the oil and gas as well. We work in healthcare. We work with some of the leading health research companies, such as Cerner, Kaiser Permanente, Amerigroup, and so forth. And labs and research, we work with Sandia Labs, we work with University of Waterloo, and Roche, which is also it's also a research in health. I guess it's more like a health or genomics. And oil and gas, we work with BHP Billiton, Total, Hess, PGS, and several others. So we have quite a big experience in moving files for the supercomputing world. So that's sort of the preview. Thank you very much for watching this. Let's get to a demo here now so you can see how things work. So before we get into the demo of FileCatalyst, I just wanted to tell you a little bit about our deployment and how FileCatalyst is deployed in your environment. So everything with FileCatalyst starts with the FileCatalyst server. So this is the server. The topology of FileCatalyst deployment follows very similar to FTP, where you at one location you have a central server where you have your user management, and you define all your users and where these users land on your storage. And then you have your internet connectivity or your network content connectivity, and you have different client applications that can connect to either push content to the server or pull content from the server. We have 5 different client applications for different use cases. So the first one will be what I'll be showing you at the demo today. I'll be showing you the hot folder application, but we also have a desktop app very similar to FileZilla. We have a browser plugin if you want to send files via the web, and we have a mobile app and an SDK. So this is, by the way, just taken from our website, so you can very easily see and get a description here of each application. So all these client applications are bidirectional, so they can both do a push and a pull. So you don't really need a server at every cluster location. You might just need one server on one end, centrally managed, and then you have the hot folder applications installed in different locations that need to push data to your cluster. So let's start with the FileCatalyst server. So FileCatalyst server is really just your user groupings, and each user, as you can see here, has a different path where you can store the data. The paths can be local, they can be NFS mounts, they could be Samba shares for Windows or CIFS, shared drives. They can also be object storage. So it could be something on the cloud. Storage could be living on the cloud. So dependingly what you need to move and where, you can define these settings, these users the way you want. Optionally, we have authentication with LDAP and Active Directory built in. And we also have the ability to create virtual files and folders. So for example, if you want to have a folder that is shared by 2 different users, you can create a folder. That folder is not really a physical folder anywhere on your storage. It's just defined in the FileCatalyst server. And then those users you can define who can read and write to this folder. So for example, here is, I'll create a virtual folder, just an example. And the physical path, it could be somewhere else on your system. So I'll just go here to this PC C drive. Let's say I'll pick this location, and now this creates a virtual folder. I can then assign different users to be able to. I can then assign different users that have different permissions to this virtual folder. Some might have read and write, some of them might have only write only, some of them might be able to only delete files. You can mix and match these to your users' contents. On top of this, virtual folders could also reside on a cloud storage or an object share. FileCatalyst server as well is can act as an FTPS server, an SFTP server, a FileCatalyst server. So if you have some applications, third-party applications that don't necessarily speak FileCatalyst, they can still use FTP to connect and drop files to the server. There will be no acceleration, but you'll get all the management tools that come with it. You'll get all the reporting and management tools. As far as security goes, we have everything is fully encrypted when you send with FileCatalyst with SSL and AES. You can import your own keys. Or you can have FileCatalyst software can generate a self-issued key as well. You can control the security by also doing IP filtering, so only allows certain IPs to connect or deny. You have full email notifications, so if there's any file transfers, you can get email notifications that what arrived. And you have a full reporting structure built in, so you can see the reporting by bandwidth or by data, and you can see exactly who's transferred what. System monitor, I'll get this into a minute. You'll see here all the file transfers that are currently happening. So that's on the server side. On the client side, we have the FileCatalyst hot folder application. FileCatalyst hot folder application is the client app that can either connect and either can push data to the FileCatalyst server or pull data from the FileCatalyst server. The hot folder, you can have multiple sites defined because you could have multiple different FileCatalyst servers, and you can have multiple hot folders defined. So you could have folder A sending files, let's say, from LA to London, and you could have another watch folder that will send files from LA to Singapore. So it's just a matter of creating these folders. Once you have a hot folder in a site, you can then create a task. And this is where all the logic of the task comes in. So you have your schedule. How often do you want it to run? Let's say every day at midnight. And any new files will either get uploaded or downloaded. So you can select the direction here of your hot folder. We can have an MD5 checksum done. So if the file is being transferred, file is transferred with a temporary file name, and then we'll rename the file to a full file name once the file was delivered. And once it was delivered, also an MD5 will be done on the file, so you know that it's 100% correct. Another option you have with hot folder is that you have something called multi-client, where you can send multiple files at once. So instead of sending just one, you can work on multiple files. This gives you even more optimization. And this will allow you also to add new files. So let's say if a task fires up and another file arrives in the hot folder while the task is running, the task will quickly rescan and add it, so you don't have to wait for the execution, especially for the tasks that, let's say, run once a day. You don't have to wait a full day for it to run again. It will just pick up that file as it's running and add it. The enable of auto archiving allows you to bundle files into a single archive and speed up the transfers through auto archival. Data minimization, this allows you to apply incremental transfers or doing file deltas, or just retransfer the file, or just retransfer the file with a different file name. So it could be, we'll add like a .1, .2 extensions if it's the second file coming through. And there's also compression built in for those that are sending a lot of textual data or uncompressed data, where you can send you can enable that and then get better performance. The dynamic files allows you to send growing files. So this is very popular in the world of video, where camera is recording which creates a growing file on the disk, and we can send this this file. You have a lot of parameters here that allows you to specify how often to check for the growing file for the growth. It's maybe in HPC world not very useful. We haven't seen clients using this too much, but there's ability to send growing files. File sets, this is where you can specify what to send and where. So you could have one file, let's say you could have one task sending smaller files, another task could be sending larger files, and you can define here as small files, large files, and have different settings. We also have the synchronization options built in. So for example, if you want to keep mirroring, so you want to have hot folder to keep a mirror image of what's on the server, you can enable this. So if someone deletes a file on a server, this file will also get deleted on the remote site. You can also specify here priority sequence. Do you want to send oldest files first or newest or whatever sequence it is? And then we also have transfer cache. So if you want to maintain the same path in both places, hot folder can memorize the files that it sends so it doesn't send them again. So this is important for those that want to do mirroring tasks. Post tasks allows you to what to do with the files once they were sent. Do you want to delete them, do nothing to them, move them to a sent folder? We can also execute a script or call a URL after the transfer. So if you want to, let's say, call another application to tell it file transfer is complete, you can do that with the post URL, and you have your email alerts. Your bandwidth here allows you to specify at what time of the day to go at what speed, and that's really important, especially for if you're sending some large data at nighttime when nobody's using the network. You can transfer these files. You can transfer these files with different speeds. Again, you have reporting built in, and as well you have connectivity to Central, which I will get in a minute. So now if I want to do a transfer, I'll just execute here a transfer, and you can see here now my file transfer is going and sending this file set. It shows you exactly the time and how long it will take. It shows you the current speed, and you have a full information on it. If I go back to the server now, you will see that on the server, now I have this information as well. So you can see the server is receiving files. You can see that there's actually two files going on at the same time because I had it set that way that it would send two files at once. And I can click here on any of the session here and get full information from the server side. There's another way to get all the information as well, and it's through Central, which I will show you in a minute. But this is the idea. Now you can be sending files. So you're going to be sending massive folders, maintain permissions, with schedule, and with sending multiple files where you're saving a lot of time on that, and it gives you a full capacity. So imagine, for example, distributing result sets like from the cluster. So cluster computes creates new file sets that you now want to share with your peers or your stakeholders. They will all have a hot folder installed on their location. The hot folder will be watching a specific folder on the server, and as soon as those result sets are ready, the hot folder will start downloading, and then at the end we'll email them that the files have arrived to their local system. So it makes the process of distributing a lot of data very fast and easy, and same thing for input or ingesting files, large input files. It also makes it very easy. So besides of all the file transfer tools that I showed you as the server and a hot folder, we also have a very elaborate management system built in where you can control all your hot folders, and other FileCatalyst client applications via the web. And this is called FileCatalyst Central. So in this case here, I just want to give you a quick demo of Central so you have an idea how this works. So Central is a management and monitoring layer of FileCatalyst. So in this case here, imagine you have a few FileCatalyst servers installed around the world. We will now, you now want to be able to manage this and at a glance to see what's going on and what's being transferred, as well as you want to be able to be made aware if there are problems. So this is where Central comes in. So Central, the way it works is that each client application, let me show you here, for example, the hot folder. Each client application and a server application has a central management tab, and in there you can configure the IP address of Central and the monitoring IP. And then once you have all your nodes created, once you log into Central, you will see all your nodes being logged in, and you will see them in the list here as nodes. Once you have those nodes created, you can create different map objects. So for example, here I created a map of United States where I have the server in New York and the hot folder in LA, and I can see the transfers. I can see the link here in connectivity. But I can load as many of these maps as I want. I can create as many as I want. So for example, here I have another map. It's in this case here I only have 2 nodes for simplicity's sake, but you would have several of these nodes with different overlays, and you can do all the reporting on it. You can do remote management. So let me, for example, show you here I can manage remotely. So I just have to click on the hot folder, connect to node. This opens up a new tab, and now I have the hot folder administration panel right in my web browser, and I can manage the bandwidth, change the scheduling. So for example here, let me just fire up this transfer. Just fire up this transfer here. So I'm just going to click on execute. And now this will fire up, will tell the hot folder to start transferring this node. So if I go back now into my map view, you can see my graph is starting to go. You can see the transfer going. You can also group objects. You can create maps where you group objects together. So if you want to have a report, let's say, show me all the data being transferred for Europe, you group them together, and you have a reporting set up for this part of the world. As another important stuff is that if you want to search, for example, give me a file name, show me all the files that PDF files that we sent. So we can do a search for PDF, and this will show me all the file transfers that contain PDF keyword in them. Of course, you can search by much more elaborate things, but this is an example. Reporting will give you a full report of the transfers. You can do it from custom dates or 3 months or whichever, and you can select which nodes you want to have controlled in this. So once again, once you have several FileCatalyst servers and many hot folders as well as other client applications, you can easily control them with this application. Some other things you can do here is that, of course, you can see the current transfers, but the big part is also the alarms. So there is an option here where you can see all the alarms in the system. The alarm configuration is done through the configuration window, and here you can specify the SNMP settings. So for example, if you want to send SNMP traps to another enterprise management console, for example, like a Cisco management console, or anything else that talks SNMP, you can send these alarms that way. So you have everything centralized. The alarm settings, you can specify what alarms you want to raise and what to do. So for example, you could say, if a file transfer fails, it can go to one person, while another alarm could be going to a different person. So you can control and manage the SNMP settings. Another way of delivering alarms is through email. So instead of sending traps, we can just send emails. So if you're not using Enterprise Management Console, then you can just use emails for that. Another part of this is that if you have, let's say, a complex deployment where you have lots of servers and clients, you can undock these maps from the browser. So each map, it will be in a different web browser, and you can pull this up in a separate screen, computer screen, and then you can see much better visibility of what's happening, especially for those things that are file transfer that are mission critical. This tool makes things a lot easier to manage and see. To go back to my PowerPoint here, we're just wrapping things up. So if you are looking for a UDP file transfer solution, well, make sure that you find one that plays fair with the network. Don't get a lot of open source products out there like Tsunami or UDT. Don't necessarily will slow down if there's other traffic on the network. So you want to make sure that's something that will speed up and slow down. Also, make sure that you find a solution that works well with latency and packet loss. So do a test. Transfer files with 150 milliseconds delay. See how it behaves. Do a test on with packet loss. So if you're going to be using public internet, well, that public internet loss is about 0.67%, I think, as of today. Like that's the average, 0.67%. So do a test with 0.67% packet loss. See what speeds you get. Make sure you have something that solution that can actually really push your disk-to-disk transfer to 10 gigabits and beyond. We can do that. Make sure you have the ability to create, security with security with encryption. That you have the reliability built in. You have the automatic resumes. A solution that can perform well with many small files. A solution that can handle 1 million files in a session. That's something that is important as well. Transferring growing files is important. Transferring multiple files at once. You get all the SDK built in, the central management console, and something that maintains all your Linux permissions, especially when you're doing an HPC where you need to have your username, your group IDs, your Unix permissions. All of this is important for that. A solution that can also send empty files, empty folders. That's something important as well to be considered. And if you are planning to be pushing stuff for iCabal to Object Store, well, make sure you pick someone that can do this. So in essence, this is what FileCatalyst offers to the HPC market. We've done the supercomputing show in Denver last year, and we were also at the supercomputing show at Salt Lake City the year before. So we do have active clients that use our applications in this domain. We have experience in this, and I hope to see you at the ISC supercomputing show in Frankfurt in just less than 2 weeks now, June 25th to 27th. We're in a stand K447. Come and see me. I will be there, and I'll be happy to answer all your questions. Thank you very much, and have a good day.